community call. I think this is about our 159th meeting, something like that. And I'll go ahead and share my screen. And don't know if you guys can see my screen. I hope so. Great. So I had to skip last week. We had some Azure Core AI learnings that we needed to do. We had 3 days of learnings or teachings, depending on who you were. So that's where I was for that. And I needed to do that. So we had 2 weeks worth of work. And so hopefully everyone received these notes. And if you didn't, please just let me know and I'll add you. We still have this volunteer up for grabs to create commands to show ENI counters and DPU global metrics. But again, a ton of work was merged over the last couple of weeks. And I think we talked about OCP coming up, and we briefly touched upon XSight Labs. And so last week there were 13 completed, and the queue seems to be ever growing. So that's usually what I'm doing before this call, is getting a handle on the work that's been done and the upcoming work. And I guess it's our 153rd meeting this week. So hopefully this format still works for you guys. I'm also sending it to that Linux Foundation email group, so they're posted there, and then the longer notes here. So these are just the things we talked about the last week. And then, of course, if you have Teams or if you have YouTube, the contents of the call are there. So I think this week, though, I wanted to give some time to XSight Labs, if you'd like, to pick up on the subject we talked about last week about the hardware.
Okay, thanks, Christina. So my name is Bud Grise. I'm an engineer at XSight Labs. Thanks for letting me talk about the E1 and Dash. So first, a little background on XSight. We're a networking ASIC vendor. Our engineers are mostly former employees of EasyChip, Cisco, and Broadcom. So we have a lot of data plane experience. We have two products. The first one is a 12.8 terabit switch called the X2. It's P4 programmable and runs SONiC. And the other is a DPU called the E1. We've been involved with the Dash project from early on, for more than 4 years ago. And we've done a lot of work on our Dash data plane, although in the last 2 years or so, we've basically been in monitoring mode for Dash while we waited for a chip to fab out. And that's because we're a small company, need to be careful about where we spend our resources. But the E1 is our first DPU, and we're pretty excited about it. We got our first chips back from the fab in March. 10 weeks later, we shipped out our first evaluation boards. Our A0 silicon was good, and that's what we'll be using for our production release. And we're sampling to multiple customers right now, and we've re-engaged on Dash now that we have silicon. So I can talk about some E1 specs. It's a 5 nanometer chip. It has 64 Neoverse and 2 cores. And these are not mobile ARM cores. These are server class CPUs. And all the cores are fully cache coherent. We have 40 lanes of PCIe Gen 5, 8 for local devices and 32 for other local devices or to connect to host CPUs. We have two 400 gigabit Ethernet ports. The E1 can do 800 gigabits per second as a bump in the wire. And in the AI NIC use case, which admittedly is a very specialized case, we can do a full 800 gigabits per second to and from the host. We have 4 DDR5 memory channels, so there's a lot of DRAM bandwidth. It also supports up to half a terabyte of RAM. It also has inline crypto, look-aside crypto, look-aside for storage acceleration, and PCIe device emulation. So in the E1 architecture, all received packets go into a hardware RX pipeline, then to the N2 cores, and then to a TX pipeline. There's no fast path where packets skip the N2 cores. But instead of this being a limitation, the architecture scales out the data paths, the DMA engines, and compute to support high performance. The maximum throughput through the Ethernet ports alone is in the hundreds of millions of packets per second. And the HERA results also show that the architecture is a good fit for Dash. So the hero test was run at we'll call it a well-known third-party testing site on one of our evaluation boards. The Hero 800 test has 128 ENIs with a very large configuration of like routes, mappings, and ACLs. And although the configuration could be loaded through the PCIE APIs for speed during the test, we instead side-loaded it by having the data plane read a local JSON file. This file had about 300 million lines of config, which is just huge, and it took about 25 minutes to load. But since then, we've made an optimization, and now we can sideload that Hero 800 JSON test file in only about 6 minutes. So that's the kind of flexibility you get with having lots of high-performance cores. To pass the Hero 800 test, the DPU needs to process 120 million background flows and 12 million connections per second of foreground TCP flows for 100 seconds with 0 drops. We did this and in fact passed the test with 14.25 million connections per second, exceeding the requirement by 19%. In addition, we only used 55 of the 64 cores for the data plane. This leaves 9 cores for running SONiC or for additional data plane performance. One other point, the E1 has a programmable hardware RX pipeline between the Ethernet ports and the N2 cores. It can do programmable packet parsing, table lookups in SRAM and DRAM, etc. We actually didn't use this hardware for the Dash Hero tests. We didn't need it to hit the performance targets. We estimate if we did, we could increase the throughput by another 25% or so. And we believe this development approach that we used for Dash is a useful one. If you want to port an existing application to the E1, you can do it, then check out the performance. If you need more performance, then you can start putting data structures into these hardware lookup tables. But if the performance is acceptable, you don't need to do this part. Our data plane is a full Dash data plane with the basic VNet to VNet feature, connection tracking and aging. Plus it implements policing, metering, counters, inbound routing, private link, and more. We also have a gRPC interface that connects to our libSci, and we've integrated with SyncD and the Sci Challenger tests. A couple other things. We've also built a traffic generator into the data plane executable that can generate millions of flows, both IPv4 and IPv6, TCP and UDP, both foreground and background traffic. We also built in a Hero configurator, which can create Hero configurations programmatically. Together, these made development highly productive. We can start up a Hero 200 class test, validate the correctness and the performance of the data plane with millions of flows and millions of packets in just a few seconds. This means we can rapidly try out new code for features or to make optimizations. We also test using an external TRX traffic generator. The data plane itself is a DPDK application written in C and C++. It was originally developed on x86 hardware. And then a few years ago, we ported it over to an Ampere ARM server, and that took about a day. When we got our E1 chips in from the fab, we ported it again, and again, that took about a day. The data plane was written by a small and very focused team, mostly by following the information presented here at these Dash meetings. We spent a lot of time thinking about algorithms and how to manage DRAM accesses and latency hiding, especially on the connection table, on aging, and on the ACL algorithms. We also chose a simple run-to-completion model that's easier to read and maintain than VPP. And this is what made it possible to develop all this with just a small team. From a software point of view, the E1 looks like a server with DPDK drivers. You can use standard development and debugging tools. You can write in any language you want. It should be fairly easy to port existing applications over to the E1. You don't need to rewrite the data plane. You don't need to pull apart existing data plane and control plane code, which can introduce new logic bugs and race conditions, and you can share the same code base. It's a very friendly development environment. In fact, for the Hero 800 test, our Dash executable was built natively on our Ampere development server. We run Dash and tested on that server. And then for the Hero test, we copied the binary over to the E1 board, and it just worked. So that's all I had. I can take a couple questions now if Christina allows it, or if you have questions, you can ping me after the meeting.
And you have your email address in the side chat, Bud? Is it bud.grise at XSight or budg at XSight Labs?
It is, yes, that's right.
Second one, right? Yep. So yeah, anyone have questions for Bud or about the 800 gig hero or the test or anything like that? Oh, morning, Michael.
Hey, good morning.
Good morning. Yeah. Great, Bud. Thank you so much. It is pretty impressive to get those kind of numbers with 0 drops. So thank you for sharing that. And if there's a use case we can work with you in the Dash community, just let us know other than the ones we've published so far.
All right. Thank you, Christina.
Yeah, thanks, Bud. Awesome. And did anyone else have a PR issue you wanted to bring forward today? Okay, then I will briefly flash. Again, this is the community project that we have. And like I said, the workload kind of just keeps churning. We still have our main to do and a few things in draft here, but the in progress list, they don't stay stagnant. Some of them stay stagnant, but they do keep growing and turning over into, they'll move to waiting review or done this week. And so I need to go through the rest of the in progress, but the awaiting review, some interesting ones are, adding the PLNSG tests, and we also have from KeySight the Smart Switch UHD config support here, and we had some work around increasing the maximum DPU timeout. In this one, it was submitted, but we need to answer the question, why would we need to increase that timeout? We've created new tables for HA automation, etc. So don't know if you guys want to talk about any of these, but these are the repos that they're in. If you see everything in green here, I can't go over every single one, but there's about 20 items that we churned through in the last 2 weeks. So we're getting a lot of contributions, and want to say thank you for that. It looks like, I'm not even sure who this person was. His name is Nan. Feng Nan just kind of came in and commented on the proto, and we accepted that contribution. And I've asked a couple times who that is, and I can't figure it out. We also have, for example, HLD for the Smart Switch DPU graceful shutdown. So I know I'm going quickly here, but another significant one was implementation of PL redirect map here by Lawrence. So that was awesome. These were the changes that were made there. Work agent and here, and then the tests. And another one that I thought was interesting was.
And last time, Christina, I believe there was some discussion that I think Reeve was supposed to follow up something, if I remember correctly. I wonder if it was closed.
Let me remember what Riff was going to follow up on. Let me pull this over here.
On the last notes. I think Reeve or Lawrence maybe. There was some action item on us that I want to basically see if.
Okay, let's see. So it wasn't, that was not the DPU platform test. We know about Lawrence. Prabhat was explaining about ZMQ connection. Was that it? The GNI config failure for first dash object? I don't see here where I have Riff set up. Let me look here. Metering counters, UHD. Was it the VXLAN source port range that you wanted to constrain?
Yeah, so that I believe Reeve needs to document or something like this. That's one thing. And we need to have a test for this, I think.
Yes. I don't have an excuse me, I don't have an update on that one, but I can follow up on that one. And then, so yeah, that's, sorry, that's the only one we would have had for RF, I think. So I can follow up on that. Okay. And then you had mentioned some versioning, Michael, last couple of times.
Yes, we need to basically check versioning of all the object if we have versions wherever we need. So we don't need to do deep compare basically when we are checking the state.
Maybe I'll just create a PR here. Would that work for you?
Yeah, not PR, more like a work item.
A work like an issue?
Yeah, something like this, right? To validate that we have versioning everywhere that we need.
Okay, we can do that. Since I'll do that, Michael. Since I had Marian here, Marian, are these two still pretty low priority, or could we close them, the session parameter bounce back and the underlay TTL?
Hey, Marian.
Hey.
Hey.
I said yes, they are low priority.
Oh, I'm sorry, I didn't hear you. I think it must have cut out. My bad. Okay, so I'll just keep those in the back. And I did check with Kumaresh, this PA validation offload to MPU. He wants to keep that open here. And then I believe there's one more that Riff was working on where he needs to update the design. This is this one, adding floating NIC packet flow and SI API design. So Riff wants to keep this one open as well. So if anyone wants to help him with those, just go ahead.
Actually, yeah, I have a question about that. Is there any? Are there any open questions? I thought it was ready to merge.
This one, number 25.
Yeah, the floating design. So there was one thing that I remember that there was discussed because the floating is a property of the ENI, not the property on the basically switch, right? So the basically switch or the DPU can have basically some ENIs which are working in the floating ENI mode, some ENIs which are working in the VM mode, right? And I believe last time someone raised the concern that somewhere this is modeled not on the ENI. So I believe it was side modeling, not so much northbound dash side modeling, but I think this was the one that I think like Reef or Prabhat or someone, I think Reef was supposed to follow up to make sure that basically modeling is actually modeled correctly there. I think that's the stuff. I'm not quite sure if this is actually for this PR, but I remember that there was an issue that we had to solve, something related to modeling that basically whether this is in floating mode or not is supposed to be on the ENI.
Okay.
Yeah, and I did check with Riff 2 weeks ago, and he just had not been able to get time for this one. But I think I saw a PR from Ramesh. I believe it was Ramesh who it talked about floating and non-floating. Can you remind me, Murali, if you happen to remember?
I think the test was from Michael.
Michael, maybe it was Michael.
Senthil and Michael. I think there is a PR that he has raised.
Yes.
I think he received some comments. I don't know if it's gotten merged. He's not.
I don't think it has. I don't think it has. I'm trying to remember which repo it's in. Let me do something real quick here.
Krishna, I think he's waiting for some more new changes. Lawrence committed, right? The ENI object, the ENI mode in the new field he supported, right? For floating weaning. Now we are qualifying that. Once that is done, he will update the PR and he will address all the comments and then he will merge it.
Yeah. Thanks for that update. I have learned to search GitHub pretty well. Let me see, 7-9. I'll do 10. Okay, and then no, I won't look for it now. I won't bother. I'll sit here, won't sit and bother looking for it now, but I can find that and put it in the chat window. So that's what has happened the last couple of weeks. And Michael, did you have anything else you wanted me to follow up on?
I think mostly I want to check with Reef on this floating NIC design because because apart from this like testing and the coding, that's one thing, right? But if something was not modeled correctly, that's kind of may change whatever basically people are doing regards to implementation, right? So that's why I want to make sure that this specific concern that was raised, I think 2 weeks ago or something like this will be fixed as soon as possible.
Okay, so say any scoop on this one, and does it have to do with floating versus non?
Yeah, and I think right now the SONiC team is building the official images based on the newest refreshed version of some images. So we will start basically some process to basically do some additional qualification on this. So we'll see how this goes.
Yeah. So, and again, a lot of HA work has also been done in the last couple of weeks between Jing and Fred at Cisco, and of course Keysight, Alberto, and Riff. So, and then I think, and then Cisco team has also been working as well to, like here, for example, creating new ports, etc. So the two that I haven't gone over was the test case to verify ZMQ reconnect, which I need to do. And I did notice that Lawrence merged this one where he was changing a field. So from the big to the little stuff, this is kind of what's going on. I'll go ahead and stop sharing. Did you guys have anything you wanted to bring up?
Michael, on the floating VNIC, this is Senthil. Michael, on the floating VNIC concept, right? I think recently Lawrence committed an additional field in the ENI table object, which supports that ENI mode, whether it's a floating VNIC or not floating VNIC. Yeah.
Okay, so maybe it was this.
Yeah. He addressed it. Recently he committed, maybe a week back or something. So, and then like that, I think it's all supported now.
Okay, awesome. So this was just in the dash side of the modeling, or there was also side changes needed?
Yeah, side changes and everything is done, both.
Okay, awesome.
Dash and side, yeah.
Awesome. Then we are good. Cool. Perfect.
Awesome.
And then do we know, quick stuff, do we know if basically he also updated tests for this or not? To basically add some tests that basically we can program in multiple ENIs in different modes per ENI. Have some other tests for this or not?
That test Cisco from Cisco team Michael has a PR. So earlier Lawrence wrote it and Michael has modified it and still he has to commit it. He's working on it.
I see, perfect. And this test basically tests the mix, right? That you have some ENIs in this mode in the other mode, right? And test basically that everything is programmed correctly, and then traffic is kind of routed with this.
Yeah, basically he wants to write something like a PL in a regular ENI in a normal mode and also PL in a floating VNIC mode ENI.
Okay.
So the two combination, the same script can run it. Yeah.
Yes, but he's checking that two ENIs can be programmed the same DPU, right? So it's not one at a time.
Right now he has written as one ENI. We can do that. Yeah, we can.
Yeah, because one at a time will not catch the issue that previously was modeled on a switch level, right? But the main thing is basically that two different ones, right, can be programmed on the same DPU. Cool, awesome.
Yeah.
Awesome, perfect.
It looks like Riff answered you too in the chat window, Michael, about getting the document updated and.
Okay, so yeah, so awesome, perfect.
Okay, great.
Awesome.
Right. So I think I've asked everyone a couple of times, but I guess I'll count it down. If there's anything you want to cover or talk about. And I know we have OCP coming up, so hopefully we'll have a couple sessions there. But yeah, I'll stop the recording and thanks everyone for coming. I apologize I had to